Greetings and welcome to the Astronomy Picture of the Day podcast. Today's picture is titled Planetary Nebula, Abell 7. So, what do we see here? Well, here we see an image of a very faint planetary nebula, relatively hard to see. Now, it looks fine here, but that's because a long exposure was taken, meaning many hours to process, and it was taken with what we call a narrow band image. Now, narrow band means we're looking at very specific wavelengths, in this case, wavelengths emitted by hydrogen and oxygen atoms. When we do that, it helps focus on the gas because that's what the gas is emitting. It emits very specific wavelengths depending on what it's made up of. So when we look at those specific wavelengths, especially hydrogen, which makes up a lot of material in the universe, and oxygen, which is quite common in planetary nebulae, we're essentially getting all of the light that the gas is emitting there. When we take a broadband image, which takes big chunks of the spectrum, then we are seeing all of the light, and we're focusing on everything, so other things would be brighter relative to the planetary nebula. So doing this sort of brightens the planetary nebula. We're essentially getting all of the light that it is emitting, but only some of the light that the stars are emitting. And it allows us to more easily see the planetary nebula, as we can tell here. Now, a planetary nebula is the end state of a star, much like our own sun. And what happens is this core will contract downward as it uses up all of its fuel and will eventually compress into something about the size of the Earth. It will still have the mass of our sun, but will be about the size of Earth compressed at the center. And you can see the bright dot at the center there is actually the white dwarf star at the center. Very hot star, maybe 100,000 degrees, and extremely dense because all of that material has been compressed into a much smaller space. Essentially, in a white dwarf, all of the atoms get compressed as close as they possibly can. You can get the electrons as close as they are allowed to be by the quantum mechanical limitations, essentially not being able to have two electrons having the exact same quantum states at the same time. And that compresses something the mass of our sun down to about the size of Earth. Now, when will our sun do this? Well, we've got a while to wait. So nothing that's going to happen anytime soon. The sun has about 5 billion more years worth of fuel in its core. So after that, it will start to head toward this stage and may take another billion or so years to actually get to the point where it has ejected its outer layers out into space, meaning that a distant astronomer looking back toward Earth, maybe 6 or so billion years from now, would be able to see something like this where our solar system once was. So that was our picture of the day, titled Planetary Nebula, Abell 7. We'll be back again tomorrow for the next picture, previewed to be Earthset. So we'll see what that is about tomorrow. And until then, have a great day, everyone, and I will see you in class.